So we saw like application layer is a place where we have some applications that can talk to the network. MS Paint is not an application for a network. So that won't be under an application layer. Even though it is an application, it won't come under application layer. But browser is a application layer. The application that talks to the internet. The command prompt, you can ping from there, you can telnet from there, many things. PuTTY is another network application. Then we saw presentation layer that picks the right protocol so that the encapsulation of the data can be done in such a way that the receiver will know how to handle that packet. That is presentation layer. And then the session layer provides the time frame so that you need not to wait for a session kept open for a long time when there is no response. So time frame is important. Fourthly, we saw a transport layer where the packets, the large packets are segmented. The big data is segmented into pieces so that it can be carried on the links without any struggle. So transport layer, as the word says, transport layer, it takes care of easy transportation. Let's say you have two containers. You have two container box. So if you have two container box, to move from your place to another place, which is like 100 kilometers away, you will rent two lorries because it's two container. So you decide to rent two lorries for two container. That is what called as transportation. You cannot transport two container in one lorry. If you keep one container over the other, this is one container. This is another container. If you keep it one top of the other, and this is your lorry. You see how tall it is, the container. Not allowed. Police will stop you. You cannot go through the bridge. Finish. Not possible. So you decide to rent another lorry, and you shift the container so that both the lorries can be comfortably, without any struggle, take you these two containers to the remote place. See, this is what called as transportation, no? Likewise, when you have a big data to send, the big data cannot be transported by your lorry, your medium. Media is what? Transporting road, no? It's a road through which you want to forward the traffic. So according to the capacity of the road, you need to break this big data into pieces. So this road can carry only this amount of piece, the size of data. So we segment it. We call it what in English? Segmenting. We segment it. We segment it into pieces. And this each segment, you can have a number called sequence number. Why should you number? So that, see, internet is a big web. Lot of wires, lot of connections. It's a big wire, big connection. It's a big mesh topology, right? So if A is talking to B here, one packet may take this path. The other, one segment may take that path. The other segment may take this path. The other segment may take this path. So depending on the latency on the link, what is latency delay? Sometime you will have your third segment reaching first, fourth segment, first segment, and then second segment. So when you arrange this, it won't give you meaning. You won't get the same data as it is sent. So only when you have a number, you can rearrange it. You can take this first segment which came late, and the second segment, and you can shift it to here, so that there will be same amount of data and same size and same sequence. So you get the same data that was sent from the remote. So sequencing is important to rearrange the segments on the remote site. Who takes care of these things? Transport layer. Next is transport layer uses these two protocols, TCP, UDP, for transportation. Both are protocol that is used by the transport layer for transportation, but both are not same. See, if you're going by an aeroplane, you are issued with a boarding pass. You show your boarding pass, and then when you get inside the aeroplane, they welcome you. They say, "Good afternoon, sir." And they smile nicely and they show you a seat. They take care of you like a baby. And then after you reach home, you get a feedback form from the airlines. How was the flight? How much time it took for you to get into the flight after reaching the airport? Did they make you to wait for a long time? How was the food served? How was the crew member? All this they ask in the feedback form. Your experience about the flight. Then you give a report, flight feedback, and they give you thanks message for the feedback. But when you go in a town bus, you know what is town bus? Local bus. When you go in a local bus, they don't even care about you. You go in, sit. You no need to ask permission whether to sit there or not. Any seat you can sit. Sometime contractor will come and give you a ticket. Sometimes you need to go and take the ticket. He's not responsible. And when you get down in a stop, no one cares whether you get down or you still sit in the seat. And no one send you a feedback form to ask you how was the experience in the town bus. No one is asking. See, both are transporting you. Both were carrying you. Aeroplane also carried you. This local bus also carried you. But this is two different transportation, right? Even though it is a transportation, they are not same. Likewise, TCP and UDP both are used for transportation in the transport layer, but both are not same. One protocol will take care of you very much The other protocol never takes care of you. TCP is called as reliable communication. You know the opposite of it. UDP is unreliable. Why TCP is considered as reliable? Because TCP demands acknowledgement. It needs feedback. It needs acknowledgement. I send you that packet. So you should send me acknowledgement saying I received your packet. TCP will wait for acknowledgement. Only if acknowledgement comes, it will send the next packet. See, TCP is very much security oriented. Before sending packet, it will send a sync packet. What is sync packet? Sync packet is only for synchronization, to check whether the destination is there, ready to receive your packet and ready to respond to your packet. Just to check the availability, TCP will send some sync packet. We call it a synchronization packet. Sync packet. Sync packet demands acknowledgement. Sync packet will wait for acknowledgement. Sync packet demands acknowledgement. That is TCP, demanding acknowledgement. UDP is best effort delivery. Best effort delivery. What is that meaning? I am doing my best. I don't know whether it is going to reach or not, but from my side, I am doing my best. That is what called as best effort delivery. You might have heard some parents saying, I am doing my best from my side. That's all I can do. If he study, he will be good in life. If not, it is his destiny. Who can change? That is the attitude of UDP. TCP is not like that. TCP is like my father. He will expect me to get good marks. He will give beatings. He will check the report sheets. If there is a mark less in any subject, he will give nicely. If I am not getting good marks, and next time he won't pay fees. You need to cry, and then only he will pay. So that forces you to study. That guarantees that the children will grow with good education. Strictness is good, no? Wherever the parents are not strict, you will see children going very bad shape. They don't come up in life. So, TCP is like a good father. UDP is like he's also a good father, but he is not that much sincere father. He will say, I treat my son as a friend. And friend will treat you as a friend only. Don't expect him to be treating you like a father. He will hit you like a friend hit you. That is to escape from the responsibility. Parents say this. I just treat my son as a friend. Because they don't want to take that crying from the child. For them it irritates. So UDP is like that. UDP will not wait for acknowledgement. Will simply send the data out. UDP will not check whether the receiver has received it or not. It won't say, it won't check. UDP won't check whether the receiver has received it or not. UDP will be keep on sending. TCP is not like that. It will send and wait. Let the acknowledgement come. Acknowledgement came. Next. Wait. Zoom. So there is a sending of packet and waiting for acknowledgement saying I received your packet. You can send me the next packet. That is TCP. That is why we call TCP as reliable communication, because it demands acknowledgement. UDP is simply a best effort delivery. Next. As TCP demands acknowledgement, we call it as connection oriented. Whereas UDP is connectionless. UDP is connectionless. This is what it means. Best effort delivery is what we mean by connectionless. It is not like, connectionless, then wireless communication. Connection oriented, then you need a Ethernet wire. No. See, what they mean connection oriented is sending packet, waiting for acknowledgement, or before sending any packet, sending a sync packet, wait for the acknowledgement. If acknowledgement comes, then it means that we are connected. After knowing that we are connected, it sends the packet. You can call it as connection oriented. So TCP is connection oriented, reliable, it demands acknowledgement. UDP is connectionless, unreliable, which is best effort delivery. So UDP is also important, TCP is also important. Even though UDP is unreliable, we cannot ignore. We cannot ignore it. Even though UDP is unreliable, we cannot ignore it. It is also important. Say, for example, going in a reservation train is good. You are guaranteed that you have a seat. You are guaranteed that one day you are going to go. This is the day I'll go, and this is the time I will get down from the railway station. Because you reserve a ticket, you know which train you are going to go and at what time you will reach. But there is an emergency. You cannot book a ticket now. You just go to the railway station. You don't know which train you will have now. No surety. But still you use it, no? You go, take a ticket, wait for the train, get into the train. Even though it is not sure at what time the train comes, what train you are going to go, you are ready to go in the train. You leave your house, you go and get the ticket and you take the train. UDP is like that. Without reservation, you buy a normal ticket, hoping that you will have a train, you go to the railway station, and then you go. Likewise, even though UDP is connectionless, unreliable, we still depend on UDP for emergency. In another word, we depend on UDP for fast communications. What is fast communication here means? I told you TCP will not send the next packet if it is not getting an acknowledgement. So it will wait for acknowledgement and then send the next packet. And then after that again it waits for the acknowledgement and then it's in. So what happens is slow communication. TCP, even though it is reliable, the communication is not fast communication, it is slow communication. TCP is slow in communication because every now and then it will send a sync packet and then it will proceed only when it receives an acknowledgement. UDP is not like that. No sync packet, nothing. I need to send 1,000 packet, it will send all 1,000 packet, boom, like that. But TCP is not like that. If you need to send 1,000 packet, sometimes you will see 2,000 packet because acknowledgement will come. If acknowledgement is not coming, you need to resend the packet because the packet might have got lost in the path. So in short, what I am saying is, for all fast communication, like what we are doing in the class, what we are doing now, live class, audio and video, no? You are hearing my voice, you are seeing my screen. This is what? Live, fast communication, live class. As I speak, you hear me. If I say, you hear me immediately. 10:18, I did like this. You did not receive it at 11:19. You received at 11:18. Now it is 19 for me. For you also it is 19, which means we are live. Streaming, fast communication. All streaming traffic will use UDP. So because it is connectionless, because it is unreliable, you cannot just underestimate it. You cannot use TCP for audio video. See, if we use TCP for our class, what will happen, You will not receive my voice continually like this. Every now and then it will break. Why, acknowledgement needs to be shared. And every now and then sync packet will also be sent. It's a dummy packet to check the connection. This all will take long time. And the receiver will not receive the data continuously. There will be a lot of break. So TCP is not good for fast communication, streaming medias. Even for multicasting, we'll learn what is multicasting later. Even for multicasting, we use UDP. Multicasting is the opposite of unicast and broadcast. Unicast is what? Sending to one person. Broadcast is what? Sending to all. Multicast is to send to a group. Just to a group you are going to send, so you need UDP for that. Because you don't know the group members, but there are some group members. If you know someone, you can do unicast. If you don't know someone and you are sending to a group of people, in that group you don't know how many, you don't know their IP address, then you need to use UDP because you cannot do connection oriented. You don't know their IP address. See, wherever you don't know the destination but you want to communicate, you will do multicasting, where you cannot use TCP, only UDP can be used. Now, UDP is not bad, it is also very important. We have seen that. Now, what we are going to see is TCP. Wherever you expect reliability, wherever you expect that connection oriented, means wherever you want a guaranteed delivery, security, you will see those applications uses TCP. Those applications that want to provide reliability, security, all those applications will use TCP. For example, file transfer protocol. See, you want to transfer a file. So that is not a streaming. That uses TCP. And then HTTP uses TCP. SSH, Telnet, likewise many protocols. All this uses TCP. So we have real-time protocol, like voice video use real-time protocol. For communication, which uses UDP, and protocol like FTP, HTTP, they all use TCP. So this is what determined in transport layer. So going back to our OSI layer. In OSI layer, you have these two options to use. Transport layer can use TCP or UDP. TCP or UDP, who decides? Transport layer. You are not going to say, hey, for this please use TCP. No. Depending on the application that you pick over the application layer, depending on the application that you have opened. See, I have opened what? Google Hangout for it to come for communication. Google Hangout is my application layer. So it will use only UDP. But when I try to write a mail, SMTP, and when you try to receive mail, POP3, they are not live, no? Sending mail and receiving mail is not live. They use TCP. That application uses TCP. So depending on the application that we open, transport layer decides whether to use TCP or UDP. So who is controlling all these things? Who is controlling the application and session layer, presentation layer? Who is deciding for the transport layer whether to use TCP or UDP? Who is going to provide the sequence number? Is it you? No. The operating system. So all these things that we have learned now is taken care by the operating system. Operating system only decides whether I should use TCP for this or UDP for this based on the application that you have selected to communicate. Now, did you get the difference between TCP and UDP that works on transport layer? Do you have any question? If you answer me immediately yes or no, we can go to next, please. Transmission control protocol, user datagram protocol, user datagram protocol, transmission control protocol. I should have said this in the beginning itself, sorry. So transmission control protocol, user datagram protocol. Good question. Thank you for reminding. I forgot to say that in the beginning. Okay, next. Any other question? All right, the next is we spoke like TCP is connection oriented. What is the meaning of that? Please answer immediately so that we can go to the next one. What is the meaning of that? We just saw TCP is connection oriented. What is the meaning? What does it mean, connection oriented? Please answer. Now you know it. Very good. So in a simple term, how you can say it depends acknowledgement, correct? Demands acknowledgement. So that is what it really means when we say connection oriented. TCP is connection oriented, meaning it demands acknowledgement. Now I'm going to explain that in more detail because this is very important for a network guy to know. So what is that connection oriented demands acknowledgement? You already know the meaning of it, but still I want to go more elaborate on it because it's a separate topic that everyone should know about TCP. So the demands acknowledgement, no, that connection oriented, it also has got another name for it. TCP IP three-way handshake. TCP IP three-way handshake is another word, another name for that connection oriented. So we are going to see how it demands acknowledgement, how this connection oriented happens, or how this three-way handshaking happens. You see, this is me. It's me. This is you. Now, we both are meeting for the first time. And we don't know each other. You saw me and you understand that, oh, he's an Indian. I also saw you, okay, he's an Indian. We are in Amsterdam airport, let's say. We are in an airport waiting for the flight. All are foreigners, so you feel bored. And then you saw me and I saw you. Ah, he's an Asian. His color, his hair color, oh, he's our guy. So what you do? You say hello, and I also say hello. And also, you say hello, glad to meet you. See, I'm not saying simply hello. I say hello, glad to meet you. What does it mean? Hello, please talk to me. For a long time, I did not talk to anyone. I feel bored. I am feeling bored. That is the meaning of it. Glad to meet you. Meaning I'm very happy. You can tell whatever you want now. That's the meaning of it. Means I'm showing my readiness to accept your packet. Hello, glad to meet you. Same way he says, hello, glad to meet you. He is also like waiting for a long time for the flight. It's another 4 hours for the flight. So he's also waiting for someone like me to spend some time as an entertainment. So he also says, glad to meet you. Which means I'm ready to talk. I'm ready to hear. See, this is what the three-way handshake means. Let me explain you with the technical thing. Two computers wants to communicate. They may be directly connected. They may be remote somewhere. Doesn't matter. Its story is same. Whether they are in local area network or in a wide area network. What is local area network short form? LAN. Local area network. What is wide area network short form? WAN, WAN. So these two computers may be local to the same network or they may be in different network which is WAN. Whether they are local or in WAN, whether they are local or in wide area network WAN, they both do three-way handshake if TCP is used. Three-way handshake is what going to happen whether you use TCP in LAN or in WAN. That's what I just finished saying. You see, A wants to communicate to B. Before that, it wants to establish connection. That's what we are going to understand. Connection oriented connection. What does that mean? Three-way handshake. What is the three-way handshaking? These two are handshaking in three ways. How you know? The first way will be like this. Hello. This is me and my sequence number 100. And I have not spoken to you before, so acknowledgement 0. So A is sending a packet with a sequence number of 100 and acknowledgement of 0, no payload, no data. It is simply sending some dummy packet just to check whether B is available, B is ready to respond. Just to check this one small thing, it is sending one dummy packet, like you and me were waiting in the airport. You simply tried whether this guy will talk or not. You simply come and say hello, glad to meet you. And he also says hello, glad. Then you understand, okay, both are simply waiting, no work. And you started talking all those things. You know what? This world is going very bad. And everything is getting broken. Finance is going down. The rate is going high. We keep complaining. And we don't do anything for that. We simply keep complaining and we spend time. Anyway, coming back to the three-way handshake. So A is sending one packet, a dummy packet called sync packet, synchronization, just to synchronize, just to establish connection, just to see whether the neighbor is ready to receive my packet. So if B receives the packet and if B is ready to respond to you and receive packet from you, B will also send a packet saying, hey, I want to talk to you. How it says, it is sending a packet with sequence number, let's say 200. See here 100 it says, it's a sequence number and acknowledgement is 0 because it's the first conversation. Now B is saying, I also want to talk. How it says? Using the sequence number 200. Now A, when it receives, it not only receives the sequence number, it will also receive an acknowledgement for the sequence number. What was the sequence number B received? Answer immediately. We'll go to next one. What was the sequence number B received? Unmute and talk. Why so long? What is the sequence number that B received? 100. Why you say 200? It's 100. B is receiving 100. So acknowledgement will be like 101. What does that mean? It is saying, tell me the next story. It's like, come on, what is next? See, it is not saying I received your 100. As an acknowledgement, it is not saying I received your 100. It says, give me 101. So B shows that it is very curious to talk. B shows that it is ready to respond to you. We call it as forward acknowledgement. So B is sending an acknowledgement of 101. And now you see, for that A is sending a packet with the sequence number 101. See, this is the end of three-way handshake from A to B. Now from B to A, the first handshake was starting here. sequence number 200, for which A is going to respond with an acknowledgement 201, and for the 201, B is responding with acknowledgement 201. See, this is forward acknowledgement. For acknowledgement, it is sending the packet. It is asking, okay, give me the 201, which means I received your 201, 200. So here it was asking 101, it sent the sequence 101. Here this is asking 201, it is sending the sequence 201 sequence. Alright, acknowledgement will be some random number. So for this three-way handshake ends here. Sending a sequence packet, receiving an acknowledgement. Sorry, here. Receiving an acknowledgement and sending the next sequence number with the acknowledgement. Acknowledgement for 200. So this completes the three-way handshake for A. For B, the first sequence number was sent here. Acknowledgement was sent here, and the next sequence number is sent here. So this completes the three-way handshake for B. So we call this as three-way handshake. Now both knows that whatever I send, he receives. Whatever he sends, I received. Both know this very well. Any three-way handshake. TCP/IP three-way handshake. Presentation layer, application layer, presentation layer, session layer. In the transport layer only we are learning now. All these 4 layers are taken care by the operating system of your device. In the transport layer, we saw the big data is segmented. So our data will be called as segments here. Our data in the transport layer, we don't call it as packet, we call it as segments. Because there only the segmentation happens. Not only that, the port number. See, there is something called port number. Why do we need port number? You see, we saw there are 2 types of protocol here, TCP, UDP. But are we having only 2 protocols? No. TCP, UDP is a type of communication. But there are many protocols like TCP, Telnet. Meaning Telnet is a application that uses TCP as a protocol, TCP as a communication method. SSH, TCP. You see, there are many protocols that uses TCP. Then how do you know whether we are doing, how the receiver know whether we are doing Telnet or SSH? To identify what service we are looking for, there is a number given. For example, for Telnet, it is 23 TCP. TCP 23 means Telnet. 23 is the port number to identify Telnet. 22 is the port number to identify SSH. FTP uses 2 port numbers, 20, 21, to send and receive files. Let me write few more things like well known, like HTTP uses 80, TCP 80. HTTPS uses 443 TCP. So like this, There are various TCP services that a computer can provide. To differentiate the TCP services, you need port number. See, when I send port number 23, the receiver will know I'm expecting telnet. If I simply say TCP, it will be confused what TCP is asking. Is he asking for HTTP TCP or TCP SSH or TCP FTP? All this uses TCP. The receiver will know you are looking for TCP HTTP only if you put the port number 80. You understand? Put the port number 80 and send it to the destination. Destination will know that you are looking for the web page, HTTP. So, depending on the application that I open, not only TCP or UDP is decided, it also decides the destination port number. So, transport layer decides the destination port number and the source port number. Source port number will be a random port number greater than 1024. Port number is between 1 to 36. I have given you some example. For example, 23 is here. After in between this and this, 23 is there. 23 is for telnet, 22 is for, likewise, for various services, port number, even though we have these many port numbers, port number till 1024 is reserved. For example, 23 is reserved for telnet. 22 is reserved for SSH. There's a reservation. There's a reservation of port number up to 1024. Greater than 1024, they're unreserved port numbers. So, source port number will be always a random port number, let's say 5555. And destination port number depends on what you do. If you are telnetting, what will be the destination port number? 23. So it will go to the destination and say 23. So as soon as you say 23, the destination computer knows that you are looking for what? You're looking for telnet. If you say 23, telnet. Right. So port numbers are assigned to the data, assigned to the segment by the transport layer. Also, transport layer does segmentation and puts the sequence number for the packet so that it can be rearranged as we saw earlier. And then now what happens? That segment will now come down to the network layer. Network layer is the place where we call that segment as packets. Your data will be called as packets when it comes down from transport layer to the network layer. So in network layer, what happens is your computer IP address, which is source IP address, and to whom you are sending the packet, that is destination IP address, remote IP. These two are assigned to the packet by the network layer. Okay, network layer's responsibility is to assign IP address. What is the responsibility of transport layer? To segment the packet, sequence the packet, decide whether to use TCP or UDP. After deciding, put the port number depending on the service that you are expecting, the source and destination port number. All this we call it as the job of transport layer. Whereas the network layer takes responsibility to provide the source IP address and the destination IP address. See, when you are saying send the packet to Raj, Raj is the destination. Raj's IP address that you will put, no? That's the destination IP address. And your own computer IP address is copied as a source IP address. Who does this job? Network layer does this job. Network layer does this job by using a protocol called IP. That's why we call that address as IP address. We call it as IP address because it uses IP protocol. Next. After the, okay, even IPv6 is also used. It can be any version, IP version 4 or IPv6. We'll talk about these versions of IP later. So these protocols work in this network layer. Next is the data link layer. So after getting the IP, it comes to another layer called data link layer. Now in this layer, what is getting added is source and destination MAC address. So you might have learned earlier, or we'll learn it later, a protocol called ARP. What is ARP? Address Resolution Protocol. What it will do, it will learn the MAC address of the remote with the help of IP address. You see, you know the remote's IP address, right? By taking the IP address, it will discover the MAC address. That is what the purpose of ARP. By ARP, your computer will know the destination MAC address, and by copying your MAC address from the NIC card, from which card? Network interface card or Wi-Fi card, your computer knows what source MAC address to put. So a source and destination MAC address is assigned to the packet, and now the packet is called as frames. We don't call it as packet, we call it as frame. At last, when the data tries to go through the wire, this is a wire. When it tries to go through the wire, it needs to be sent in 0 and 1 format, right? Binary format. That is how the data is sent over the wire. So all this, informations are converted into this binary format by physical layer. Physical layer. So physical layer is taking the responsibility of converting the frame and translating it as, taking the frame and converting it as bits so that it can be sent over the Ethernet wire. So this is what happens on the sending side. On the receiving side, you see the receiving computer, no? The B computer. The B computer receives the packet. Packet enters where? Packet enters via the physical wire. Packet enters via the physical layer. And the data link layer will check whether the Received MAC address is matching with its own local MAC address. See, the destination MAC address should be whose MAC address? It should be B's MAC address. If B finds its own address, MAC address, then it will check the IP address. If B will see its own IP address matching, then B understands that it's my packet. Then it will check the port number. Oh, 23. It understands that I need to provide telnet service. So it talks to the operating system. All right. This is data link layer. This is network layer. IP is checked. And then in the transport layer, it understands that the port number is 23. So it changes the session ID, means it changes the session number, saying, okay, I received the packet. Now session ID means time. It gives the time, at what time it has to be, it should respond, like session, time related. And then it talks to the application that supports telnet, and then the operating system understands and provides the telnet service to the remote. So what I'm coming to say is, everything that you added from the top here will be read one by the receiver to understand what you need. Once it reaches here, the receiving computer knows what you want. Accordingly, it will respond by adding again the 7 layer, and it will send it to you, and you will receive it, and you will check it, and you will understand it. So we call it as encapsulation and decapsulation. Encapsulation is on the sending side. You send all the 7 layer. On the B side, on the receiving side, it reads one layer after the other to understand what you expect. We call this decapsulation. So OSI layer helps to encapsulate and decapsulate data between sender and receiver. So that this encapsulation and decapsulation helps to communicate each other. Right? So we have learned the OSI layer thoroughly and finished it today. In our next class, we are going to learn about some protocols like ARP, DNS, HTTP communication, and so on. Followed by, we'll get into IP addressing topic, which is class A, class B, class C addresses, followed by subnetting and so on. Well, let's go one by one. So today what we have learned is OSI layer. We started from transport layer and we finished till physical layer, and we have seen overall of three-way handshake, TCP, UDP, and OSI. Any questions? Right. I'll send you